Hello everyone, in this video I'll be explaining you the problem flip square submatrix vertically, and it was asked in weekly contest 462. So yeah, let's read out the problem, and it is easy problem. So you are given m cross n integer matrix grid and three integers x, y and k. The integers x and y represent the row and column indices of the top left corner of a square submatrix, and the integer k represent the side length of square submatrix. Your task is to flip the submatrix by reversing the order of its row vertically. Return the updated matrix. So I think it's very easy. Don't panic. So let me explain you what they're saying. We have 1 2 3 4 5 6 7 8, okay, 9 10 11 12 13 14 15 and 16 we have. This is one of the submatrix whose size is 4 cross 4 only. In this case m is 4 and n is 4, and let me see what is x and y. 103, okay. So we have x as 1, y as 0 and k as 3. So this is one of the matrix and its size will be m cross n, but in this case it is square only because both m and n are 4. So they have given x and y, and this is basically the x represents the row. So this is 0, so this is first, this is second, and this is fourth. So since row is 1, will come here, and this is columns, column 0, this is column 1, this is column 2, and this is 3. So you'll have to come to column 0. So here is the intersection point. So this now you will have to this is basically the now you'll have to find the square submatrix in the reverse order. I'll tell you what they are saying basically. So whenever they give x and y, so you'll be finding, okay, this is the submatrix, square submatrix, okay, and its size will be k cross k, and the top corner, top left corner, whatever we have, it starts from x comma y coordinates. So this is what they're saying, and k is equal to 3 represents 3 lengths you'll have to see. So this is 1, this is 2, and this is 3. So we have this thing here, and 3 lengths down you'll have to take 1, 2 and 3. So this is what is the submatrix that you need to reverse, and by reverse what you will be doing is basically you will be reversing the rows. So this row will be swapped with this row, first and last will be swapped, and if you have other rows will be swapped. So if you try to swap this, so now let me write this matrix. It will be 5 will be swapped with 13, so it will be 13 and 5 here it is looking. Now 14 and 6 will be again swapped, and this 7 and 15 will be swapped. And since this is the like one matrix, I mean one row, so this can't be swapped with any other thing, so it will be as it is 9 10 and 11, and whatever rest all elements you have, right, apart from this submatrix, whatever you have, you just copy it down. 1 2 3 4, and this is 8 12 and 16. So this matrix you need to return. So yeah, this is the thing that you'll have to return. See, it is starting from the corner top left corner, whose indices are 1 comma 0, which is x1 comma x comma y, and you should take 3 distance to the right and to the downwards, and last row will be reversed with the first row. So yeah, 13 14 15 we are getting, and 5 6 7 we are getting, and rest all elements are same. So I think you guys got problem statement. And how do we solve this? I'll be telling you. Let me take if you try to take this example as well, x is 0, which is this row, and y is 2, so this is second column, and k is 2, so 2 sides you'll have to take rightward and 2 sides will take downward. So one question arises, what if the size k is greater than the like basically it let's say for this, if k is 3, so you'll have to take 3 I mean from this position you'll have to take right side 3 elements, but you don't have 3 elements, you have only 2 elements. So this is actually dealt here in the constant they have given. So always whatever k value they have given, it will be within the bounds. so you don't need to take worry about that. So let me tell you how to solve this. So yeah, it is easy only. um, what we'll be taking is, we'll be taking we'll be finding this row, which is the row that you will have to swap, and the like this row will denote it as start row, and the next end row will be at this position, so this will be end row. So start row, how it will be, so your start row, it will be basically x only, like x is 1, so your start row will be this only. What will be your end row? End row will be x plus k minus 1. Why minus 1? Because it is a zero based indexing, so that's why you'll have to take it. Since like not zero, yeah, it is zero based indexing as well, because now if you do x plus k, which will be 4, but you don't have fourth, right? Like if you take fourth one, your row end will come at this position, but you need to take one less than that, so that's why minus. So that will give you, like, this is the first row and this is the last row. Now you'll have to take one more, this column. So start column, that will be actually y, and end column, I'll take it as y plus k minus 1. So yeah, this again, y plus k will give you 0 plus 3, which is 3. So you will be coming at this position, but this is not what you require. You will be requiring till backward one, so that's why minus 1. So, and once you found these things, so you will be running a for loop from start row to end row, and you will be swapping the columns. So let me tell you how you will do it. First, let me put this video at the corner, and let's try to solve this. You will take let me don't take m and n. I'll take start row, which is x, and end row, which is x plus k minus 1. I'll take start column as y, and I'll take end column as y plus k minus 1, right? Now I'll be running a loop which will start from start row and less than equals to let me don't run for loop, let me run a while loop, because we are swapping those columns, right? So start row less than end row. So I'll take a loop now, which is column wise I'll be swapping, like for particular row, 2 rows, column wise elements I'll be swapping. So your column will start from start column, and column will go until end column, j plus plus. Now what you'll have to do is swap with I'm not using any extra vector here, I'll be doing in the original vector only. So one can do in other vector as well, but I'll be doing here only. So this is start of row, and with j comma grid of end of row with j. You understood, right, this one? So once you swap all the j elements, like you have swapped the first and last row, now you will swap the second row and second last row. So for that, start row will be increased by 1, end row will be decreased by 1. So once you come out of the loop, you will just return this grid. Let's try to run the code. Yeah, it is getting accepted. Let's try to submit the code. Yeah, it got accepted and it beats 100% of the user. So I think if you try to analyze the time complexity of this, yeah, this one is taking k times, because that is the length of the sub square that we'll have to swap, and this one is taking k by 2. Why k by 2? Because every time we are taking 2 elements and reducing by 1, so only k by 2 times it will be happening. So in worst case it is k square, and space complexity is O of 1, since we are doing in grid only. If they were asked to do it in other vector, you don't need to touch the original array, then in that case your time and space both complexity would be m cross n. So yeah, this is I think one of the most optimal solution, and yeah, thank you guys for watching the video.